Hello and welcome to a short calculus lesson on the differentiation of a product. And by a product, we mean the product of two functions. So in this lesson, I will derive the general formula for finding the differential of a product, and then I'll apply that formula to these three problems. Y equals x squared multiplied by sine x, y equals e to the x multiplied by cos x, y equals x plus 1 squared multiplied by x minus 2 cubed. We begin by expressing y as a product of two functions u and v, where u is a function of x and v is also a function of x. And we let x change by a small amount, which we call delta x. And if x changes by a small amount delta x, it'll cause small changes in u and v, which we'll call delta u and delta v. And then in turn, those small changes in u and v will cause a small change in y, which we'll call delta y. And that will give us a new equation, y plus delta y is equal to u plus delta u multiplied by v plus delta v. And now I'm going to expand those brackets, so I get y plus delta y is equal to u multiplied by v is uv, u multiplied by delta v is plus u delta v, v multiplied by delta u is plus v delta u, and finally delta u multiplied by delta v is plus delta u delta v. So there's the 4 bits of multiplication expanding the brackets. And now I'm going to number the top equation number 1 and the bottom equation number 2, and I'm going to subtract the top equation from the bottom equation. So on the left hand side, y plus delta y minus y becomes delta y. And on the right hand side, the UV's are going to cancel. UV minus UV disappears, and I'm left with these three terms here. So I have delta y is equal to u delta v plus v delta u plus delta u times delta v. And at this point, I'm going to divide the whole equation through by that small quantity delta x. So I get delta y over delta x is equal to, now u delta v divided by delta x, I just have to divide one of those factors by the delta x and we'll make it the delta v. So that becomes u delta v over delta x. The second term, I'll divide the delta u by delta x. And the third term, it doesn't really matter which one. Let's say we'll make delta u divided by delta x. What I'm going to do now is let delta x tend to 0. Now as that small change in delta x tends to 0, the small changes it caused in u, v and y will also tend to 0. So delta u, delta v and delta y will all tend to 0. But the limits, delta y over delta x, will tend to what we call dy by dx. And that will be equal to u multiplied by the limit as delta x tends to 0 of delta v over delta x, which is dv by dx. And the next one will be v du by dx. And the last one will be du by dx, but delta v is tending to 0, so this du by dx will be multiplied by 0. And so that last term will be 0. And we're left with dy by dx is u dv by dx plus v du by dx. And there it's summarised. d by dx of uv is u dv by dx plus v du by dx. Now how can you usefully remember that? Well, this can be helpful. You can think of it as the first term multiplied by the differential of the second plus the second term multiplied by the differential of the first. Now let's put this into practice. Y equals x squared sine x. If we want dy by dx, it's equal to the first one, x squared, multiplied by the differential of the second one. And the differential of sine x is cos x. Plus the second one, sine x, multiplied by the differential of the first one. And the differential of x squared is 2x. And I've left space to put the 2x in first because we normally write x's before trigonometric functions when they multiply together. The second example, dy by dx is equal to the first one, e to the x, multiplied by the differential of the second one. And the differential of cos x is minus sine x. So I'll put that in a bracket because of the minus sign. Plus the second one, cos x, multiplied by the differential of the first one. And the differential of e to the x is e to the x. Now we can tidy this up. I could take e to the x out as a common factor. And what's it multiplied by? Cos x minus sine x. And that completes the differential. And the final example, y equals x plus 1 squared multiplied by x minus 2 cubed. dy by dx is equal to the first one, x plus 1 squared, multiplied by the differential of the second one. Now the differential of a bracket cubed is 3 times that bracket squared multiplied by the differential of the bracket. But because x minus 2, the differential is 1, there's nothing else to add. Plus the second one, x minus 2 cubed, multiplied by the differential of the first one. Now the differential of a bracket squared is 2 multiplied by that bracket to the power 1, which I don't need to write, multiplied by the differential of the bracket, and again the differential of this bracket is just 1, so there's nothing else to add in. Now let's tidy this up. What common factors have we got? We've got a common factor of x plus 1 in each of these terms, and we've got a common factor of x minus 2 squared. Now let's rebuild this expression. What do I need to multiply this by to give me this term here? Well, I'll need another x plus 1 to get it up to squared. And I'll also need to multiply it by 3. The x minus 2 squared is already there. Plus, what do I need to multiply this by to give me this term here? Well, the x plus 1 is already there, but I'll need to multiply by 2, and I'll also need to multiply by another x minus 2, because we've only got x minus 2 squared at the front, and we need x minus 2 cubed. So this comes to x plus 1, x minus 2 squared, and what have we got here? We've got 3x plus 2x is 5x, 3 times plus 1 is plus 3, 2 times minus 2 is minus 4, and so that's minus 1. And that completes the differential. That's dy by dx. Let's take this one just a little bit further and say, well, if we were looking for stationary points on this curve, we would set dy by dx equal to 0. And stationary points occur when dy by dx is 0. Well, because it's in a factorized form, when is dy by dx equal 0? we can see that it's when x is minus 1, that bracket would be 0. When x is 2, that bracket would be 0. And when x is 1/5, that bracket would be 0. So we would expect stationary points at the values x is minus 1, x is 2, and x is 1/5. Well, let's have a look at the graph. Here is the graph of y was x plus 1 squared, x minus 2 cubed. And you will see that there is indeed a stationary point which is a maximum at minus 1. There's a stationary point that's a minimum at 1/5, that's 0.2. And there's a stationary point that's a point of inflection when x equals 2. And that completes the lesson.